Oh, hi guys, and welcome back to this, our second of what is going to turn out to be 3 overview and review lectures. I know I had originally intended there to only be 2, but as I was writing the script for this one, there's just so much content that it's going to take an extra lecture, so that to everyone's benefit, I hope. In this lecture, we are going to review our discussion of procedures and functions. In particular, we're going to go through that procedure we wrote to parse an XML file. Also, the procedure we wrote to look for and identify new files within an external directory. And then our password strength function. Should be great fun. We'll see you on the inside. Hope you learn a ton.
If you'll recall, our first example procedure involved the parsing of an external XML file into a corresponding relational table. Wow, talk about real world. How real world can you get? We began with a little setup work. As you'll recall, B files require an associated external directory from within the computer file system wherein the physical files are stored. For security reasons, Oracle accesses that physical file system through an internal named directory object. As such, we began our example by granting the create directory priv to our schema and then created a local directory object which pointed to a directory in our physical file system. We concluded our little setup work by creating a local table to store our XML B files and finally added a record to that table to represent a true file out in our physical file system. Remember, there were a number of potential problems associated with getting that first record insert to work. In particular, 1. File name literals must be exact. 2. The directory object name must be in all caps and quoted. 3. The XML formatting must be perfect. And 4. Oracle must have full read access privs to that external directory. Once we were able to finally get that record inserted into our B file table, we were ready to write a procedure which parsed the external XML file and stored it to a local relational table. Very cool. We began with a discussion of procedure signatures, i.e. the external facing procedure interface. If you'll recall, we start off with the keyword create, the optional but always included keywords or replace, and then the keyword procedure followed by the procedure name. In our example, the syntax was simply create a replace procedure, read game file. The procedure signature then includes a comma-separated list of passed parameters. Parameters may be passed into the procedure, out of the procedure, or both. Parameters may be data primitives or user-defined, wherein the level of complexity is limited only by the calling program. That is, you have PLSQL procedures being called only by other PLS procedures. You can go as complex as you like. You're calling these guys from .NET or Java or something like that, then you have to stay within the structures those languages can handle. Finally, the procedure signature is culminated by the keyword as or is. The next portion of our procedure is the declaration block. This is where you're going to declare local variables, define local subroutines or embedded routines, and set up local data structures. If any of those variables is instantiated with a default value, that syntax is also available here within the declaration block. For our example, things are pretty simple, and we simply had a bunch of primitive data types in here, some with default values, others without. We then discussed the procedure body and how its onset is marked by the keyword begin and culminated with the keyword end followed by the procedure's name. Important point here was that PLSQL procedure blocks and or flow control structures must always contain at least one valid executable statement or the compiler will generate an error. Finally, our final section of the body is officially optional but should always be included. the exception handler. Here you see my standard debug handler, but as I've said previously, once I'm ready to send a piece of code into production, I normally replace this code with a message sending the user to the DBA. Oracle error messages are just too messy to be consumed by any end user. And at this point in our example, we're actually able to start learning about the various syntax options available for parsing an XML file into a local relational table. If you'll recall, our example XML file was set up in a classic master-child configuration with the master or parent information at the top of the file and then the repeating child information at the bottom. Very common stuff. Remember how we used the extract value function to retrieve the non-repeating master information from the top of our XML file? Sure, we just followed down the tag tree to our desired information and then extracted it into a local variable. Why was this so cool? Because the actual physical XML file was residing outside the database where it belonged in our physical file system. Our B file pointer type used in conjunction with the XML type allowed us to reach directly into that external file and pull out our specific information. All right, moving down our procedure code, we were then introduced to the substring and instring functions. Real common, guys. As you'll recall, the substring function takes 3 parameters and returns a substring. The 3 parameters are the original string, the character position of the substring starting location, and then the character position of the substring ending location. Easy stuff and something you have almost certainly seen in other programming syntax. Instring is just as cool. It returns an integer. Here we have 2 parameters, the original string and then string to search for within that original. The function returns the starting location of the substring from within the original. If the substring is not found, the function returns a 0. Remember that Oracle treats the start of a string as position 1, not 0. Sorry gang, not my fault. I do consider it a bad decision though on their part. We then move down our example procedure a little further to the select max plus 1 and null test. Classic method by which to get the next available value of an increment field. In our case, the next available game ID. Things to remember. The null function takes 2 parameters. If the first parameter evaluates to null, then return the second parameter. In our case, if max game ID plus 1 evaluates to null, return a value of 1. Otherwise, return the value of max game ID plus 1. Net, get me the next game ID value. If this is the first time we've ever dug into this bucket, give me a value of 1 and we'll start from the beginning. Finally, down near the bottom there, we do an insert of our new master record. Check out the use of a pair of inline views. Hey guys, that's elegant. We then moved on to extraction of the repeating or child elements from within our XML file. This is the syntax for retrieving the first series value from within our external XML file. Similarly, this is the syntax for retrieving the team attribute of the second series element. Well, certainly it doesn't take much imagination to go from that literal syntax to a more generalized solution. This syntax here utilizes the loop control variable of a for loop to provide the more generalized solution. Have nested repeating groups? No problem. Nest your for loops and use multiple differing LCVs. Finally, remember the exists node function returns a 1 if the specified tag exists and a 0 if it doesn't. Don't know how many elements exist in a particular tag collection? No problem. Do the exist node test and exit the loop if it returns a 0. Net, parsing an XML file into a relational table is pretty easy stuff given Oracle's very powerful XML parsing functions. In Lecture 10, we looked at a procedure which went out to an external directory and came back with a listing of all the files in that directory. Classic example of an Oracle predefined procedure saving us a ton of time. Let's not reinvent those wheels. If you'll recall, we started out by logging in as sys and creating a little procedure called get new files. This procedure leveraged the Oracle predefined procedure called dbms backup and restore search files. This procedure works like the old classic dir command in DOS or an ls in Unix. Net, I want a listing of all the files in this directory. What were the takeaways from that procedure example? 1. Oracle supplies a bunch of predefined procedures, some of which are undocumented. Use those guys, they will save you a ton of time. When it comes to this, Google's your friend here because the Oracle docs sometimes hide routines owned by sys. Takeaway 2. To reference the myNFL users object from the sys schema, we had to use dot notation. We did the same thing when we were going the other way from myNFL into sys. 3. The list of files created by our search file procedure was stored to an $X table, i.e. a memory table. These guys are commonly used by sys to store information for a temporary period of time, commonly associated with the views made available by sys. 4, and finally, that little procedure example also reinforced the use of a for loop with an inline view. As I said before, I really like these guys because they are relatively self-documenting. Our second procedure example of Lecture 10 was created under the myNFL user account. We again used dot notation to reference an object outside the current schema, used another for loop with an inline view, and then culminated our example by using a very cool insert statement which utilized a select and existence check subquery. Net, don't do the insert if the record already exists. Common practice and a very cool little example. Talk about real world code. Gang, that is the kind of code you'll be writing on a daily basis. We culminated our discussion of PLSQL procedures with a look at the SQL developer debugger. Nothing really too surprising or interesting here, as this debugger works very much like every other one you've seen. Net, give yourself some practice with it and you'll become an expert overnight. Remember, however, to never compile production code with the debugger's option still enabled. Slows your code down. And also, remember that the SQL developer's IntelliSense is just as stupid as all those others supplied by IDEs. Do not trust that thing, it is often wrong. Trust your eyes and the compiler. Alrighty then, we moved on to functions in Lecture 11. If you'll recall, in Lecture 11, we created a function which accepted a user-supplied password and returned an integer in the range of 0 to 100, representing the relative strength of that password. Again, a nice real-world example. However, you may also recall that the algorithm we used for this password strength function came off the internet because before writing this lecture, I simply didn't know anything about it. Learning objective number 1 for Lecture 11. The internet is full of free code. Most of it is overpriced. It's junk. Why crappy coders feel it necessary to share their creations is beyond me, but it's certainly very common. Learning objective number 2 for that lecture, reverse engineering in online form is hard work. Take your time and make certain you fully understand all the code nuances. All right, I get off my soapbox with respect to free code on the internet. Let's discuss what we learned about the calc password strength function. First and foremost, all functions must return a data type, either primitive or user-defined. Other than that, their signature is exactly like that of the previously described procedures. What is cool about the return of a data type? You can use them in select statements if they return a primitive, and you may always use them as the right-hand operand in an assignment statement. Next, we saw an example of using an index by table type declaration and instantiated that guy across 3 local function variables. If you'll recall, we use those local structures to store the upper and lowercase characters as well as the keyboard symbols. Hey, that's what real-world examples do. They take the fundamental stuff we learned earlier and put it in place to solve real-world issues. Other things we saw in that function example. 1. The existence of a locally embedded subroutine. In our case, we had one which populated the local data structures before we started analyzing the password. Remember, when you create these embedded subroutines, you do not include the create or replace keywords, but you do still need to qualify the end keyword with the subroutine's name. Learning objective 2. We then spoke about the scope of variables. Remember, variables declared within the parent routine are available to the parent as well as all embeddeds. Variables declared within the embedded routine are limited in their scope to only that embedded routine. Learning objective 3. Next, this little example gave us a chance to walk the length of a string with a for loop control variable, thus looking for sequences, repeating characters, stuff like that. Very common usage and handy code to know. Probably best to put that stuff to memory. 4. Finally, always remember to return the appropriately typed variable from within the body of your function. Forget that and your compiler's going to throw an error.
All right, guys, that concludes this lecture. In our next and final lecture, we'll finish up our overview and review section by looking at our second function as well as our packages. Should be great fun. In the interim, hey, you go out there and have yourself some fun, but learn something every day. It's what's important.